series of videos that I'm doing to catch up after Friday's problems with the network. And what I asked you to look at before today's lecture is a web page, which is the interview bit page that I've been using for a lot of this, and a Stack Overflow question and its answers. And the interview bit page has these operations that you can do on a stack, right? There's push, pop, empty, size, and peak, or sometimes it's called top. And I thought I'd quickly review what a stack is, right? So a stack is really a first in, last out. So when I push, I'm pushing onto the stack, right? And when I pop, I take whatever's was last pushed and take it off the stack. So that's the pop operation. Okay, so this one here was the first thing pushed onto the stack. This was the second thing pushed onto the stack, and this was the third thing, right? So first in, last out is what's happening here. And that's different from the next data structure we're going to look at, the queue, which is first in, first out, or FIFO, right? So in a FIFO, you come in and you come out, okay? And it depends on the size of the queue. And so this blue one is for a queue. Okay. The other thing we talked about is really you only need push and pop, right, in order to do a queue. However, there's some other operations that might be useful. We might need to know whether the queue is empty. We might need to know how many items are in the queue or the size of the queue. And we may want to have a look at the top entry without popping it off the top of the stack, just in case there's something there. Okay, so they're the other operations that you will normally see in a standard stack. The only comment that I had in class is how poorly this method is named, right? Normally, if you're naming a method, you want to use a verb, because methods are usually doing words. And if I see a method that's called empty, when I read that, I think, oh, that is going to empty the stack. And it's not. What it's doing is it's checking to see whether the stack is empty or not. So it returns true if the stack is empty, or it returns false if there's something in the queue. So a better name for that is probably the way they put it here, is probably is empty. And any time you have a status check like that, it's going to return true or false, you're better off using the verb to be in some description. Is empty, is full, is ready, is waiting. Okay? Or sometimes has availability, or has customer, or has server, right? So the thought is that when you read the name of the method, it naturally assumes or shows you that it's returning something that's either true or false. So the other piece that we looked at, or that I asked you to look at, is this Stack Overflow question that talks about implementing a fixed size stack. Okay, and that's kind of interesting because what it does, and you can see from the implementation there, is when the stack gets too big, there's too many items, it removes the first item, right? It removes the oldest item, and that's kind of interesting the way it's doing that. And the question I wanted to talk about, you know how I usually have a discussion in breakout rooms during class. The thing I wanted to think about during class is, does this work for our fixed size logging problem? And the couple of in-class discussions we managed to have without the remote people, unfortunately, was we probably don't have enough information about whether a stack would be a good fit for this problem. And the examples we gave was, what happens if you need to search through the log? If you need to search through the log, then the standard implementation of a stack is no good, because it doesn't let us do that. But we weren't told that we needed to search through the stack. So my statement was that we needed more information about the problem before deciding whether this fixed size stack was a good thing. Remember, the whole reason for the log, or the whole problem with the logging issue, was that we only needed to store 24 hours times 60 minutes, so one log message per minute. And we didn't want it, we were in a memory constrained system, so we wanted to use as little memory as possible. Okay, that's it for this video. I'm going to talk about the slide decks in the next one, and there's some asides that I need to make that I made in class that I think